want to welcome everyone today. My name is Brian Coward. I'm the EDM Product Line Manager at Makino. Today we're in the Makino Experience Center, and we're going to be discussing Wire EDM programming techniques today. So first I'd like to give you a little overview of what we're going to be talking about. So we're going to talk about some slug removal strategies. These are ways that you can optimize your programming. We're going to talk about no-core programming, which is pocketing, and then 4-axis programming. Once we talk about these in the presentation, we're going to go to Alan Weeks from Optisolutions, and he's going to give us a demonstration of the Opticam software. So let's get started. So first, slug removal strategies. Standard slug removal strategy, we're going to discuss that, explain what that means. Then we're going to go through early slug removal and a slug removal after all of the rough cuts. So what do those mean? So a standard slug removal strategy. In Opticam, how am I going to make this work? Well, the first thing I'm going to do, I'm going to come in here and I'm going to select my workpiece, and it'll bring up this window, and I'm going to not check do all first cuts before finishing. This is a strategy page of the workpiece itself. Next, I'm going to go to the profile. So this profile here is for the holes that are inside of this particular part that we're looking at. And when I hit the profile, I go to the setup page and the tagging page, and you can see here, tag removal method. I have many options of what I can do. For this particular demonstration, or this strategy, we're going to use stop, then wire cut tags on the first cut. Since this is a part where I have features internal and external, I need to set up a strategy for the outside of the insert. So I'm going to click on that particular profile, go to the setup page, tagging page, and I'm going to wire cut the tags at the end of the operation. So I got a little video here to show you, by setting up our program that way, how it's going to function. So now that we've programmed it that way, it's going to show us or simulate what it's going to do. So we're going to rough the holes. It's going to come to the stop. Then we will drop the slug. So every hole internal, these are core pin holes and ejector pin holes, it's going to follow the same pattern. We're going to rough it, drop the slug, and then finish cut it. So that means every time I'm dropping a slug, the operator needs to be there to remove the slug. So this will go through all the holes internally, because that's what we told it to do. Now once it's done with the holes, it will go to the insert itself on the outside, and it's going to go all the way around to roughing it, because we told it to wire cut the tag at the end of the operation, and then it's going to go around and skim cut it with the tag still connected. And then it'll come to the stop there, and then we cut it off, remove our part, and the part is finished. So that's what I would call a standard strategy for slug removal. So next we're going to talk about the early slug removal strategy. So again, we're going to go to our workpiece, go to the strategy page. Now, unlike the first time, where do all first cuts before finishing was unchecked, we're going to check that. We go to our workpiece profile. These are for the holes. Same thing. This is the same thing we did before. Stop and wire cut tags on first cut. The insert itself, we go to that profile, go to the setup page, tagging page. Again, same thing. Wire cut tags at end of operation. So the only thing that we've changed is on our workpiece, telling it to do all first cuts. So just by checking one box, now this video is going to show how that will function. come in here. Simulation starts up. And now we did the same thing that we did before, right? It went to the stop and we removed the slug. But now instead of finish cutting, we're going to rough all of the holes first. So we're going to go around, rough all these holes and drop all of the slugs. Now you might say, well, why would I do that? Well, because the idea is to minimize the operator intervention time at the machine. So by doing this, the only time I need to be at the machine is when I'm dropping those slugs for those holes. So once I've dropped all the slugs, now it's roughing the outside of the part. All of this is unmanned machine time. Rough the outside, now it goes back to the holes. It's going to finish it. All of this is going to be automatic without the operator being there. And then it's going to go and finish the outside of the block. And then we're going to drop the part off. It's going to be the stop, operator comes back, and we cut the slug, and the part's finished. So what we've done simply by checking one box was maximize our unmanned machine time, which is how you make money with Wire EDM. So the last slug removal technique I want to talk about is slug removal after roughing. So same thing we did on the last one. We're going to go to our workpiece, and it's going to say do all first cuts before finishing. Next we go to our profile. These are our holes. Set up tagging. Now this time, instead of clicking on stop wire cut tags on first cut, we're going to go down here to the bottom and say wire cut tags at end of all first cuts. Profile for the outside of the part is going to be the same. We're going to have to go to setup and then wire cut tags at end of operation. So again, we just changed one more thing, and now this is how this video will show you the simulation of that. So on the last one, you remember we went and we dropped all the slugs and then it roughed and skimmed everything. Right here, now what it's doing is it's roughing everything without dropping the slug. So that means that the slug is still intact on the inside where the holes are. So it roughed all the holes, now it's roughing the outside of the block. Now you might say, why would I want to do that versus the way I did it before? Well, let's say I'm setting up the part right before I'm getting ready to go home for the night, and I want to get as much machining done while I'm not there as possible. By doing it this way, I get all the roughing done. Come back in the morning, I drop all the slugs. So I don't have to stay there to drop the slugs, right? I can leave immediately. So now when I come back in the morning, I hit start, drops all the slugs. And now once I drop all the slugs, again, I'm done. I can walk away, I can go do something else. It's going to skim cut all of the holes and skim cut the outside of the block as well. And then once it's done with the skim cut, again, we're going to cut that tag. There it is, part's done. So, very easy to change our process, right? There's one nice thing about this software. We can click one button, hit post again, and totally change the way that we're going to process this job. So that's just a few of the options that we have. There's many other ways that you can do it, many other tag removal concepts, but those are kind of the three major ones that I wanted to touch on today. So next, I'm going to talk about no-core machining. So no-core machining, what does that mean? Well, essentially it's pocket machining using the Wire EDM. If you're familiar with doing a pocket machining on a mill, same concept, but we're using the Wire EDM instead of an end mill. And what does this do for us? Well, it eliminates the need for slug management. So why would I want to do that? So if you think back to what I just showed you, we're dropping those slugs. We have to think about how we're going to process a job, when we want to drop the slugs, when we want the operator to be there. That eliminates that. This is primarily used for small features because Wire EDM is a slow process. You don't want to have a really big opening and no-core it because it's going to take forever. But for small features, it's very, very effective because if I have a small feature and I'm going to cut it like we did the first examples, I'm going to get a little sliver. And it's not going to be a big slug, and that can cause all kinds of problems in the machine. So using a no-core technique is very good in those particular instances. To keep in mind when you do no-core, the roughing NC code is created without an offset. Okay, so what does that mean? Well, I'm going to show you. So to do a no-core, we're going to go to the workpiece, and once we open the workpiece, there is a tab that says no-core and start hole. So we go to start hole, and we can tell it what kind of start hole we have. Is it a round hole? Is it a irregular shaped hole? You could even make that, you create another figure inside of whatever shape you're cutting, and it could be an irregular shape. 9 times out of 10, it's going to be a round start hole. And then you would put in your diameter of how big it is. And then you just simply check the box, no core, pocket first, and then you want to give it a step over distance. So that means how much of a step over am I going to have when I'm doing the no core. For Makinos and the technology we have, 8 thou, if I'm using 10 thou wire, seems to work the best, so that's why I use the 8 thou. And then I also have options on the pocketing mode itself. So I can either do a concentric, where it's just stepping over that 8 thou amount and cutting a circle, right? Step over, cut a circle, step over and cut a circle. For this particular job, I use spiral. So once I do that, then I go to my cut control page. I go to setup page, cut control. And right here in the roughing offset, this is where we load our cutting offsets and cutting power settings, which you'll get a demo of that from Alan a little bit later. But for no core, you'll get this message if you hover your mouse over that first offset. It's going to say no core is set. Value entered in this edit should be the wire radius, spark gap, and finishing allowance per side. The reason for that is that it's not going to apply an offset. So when you do your no core, the geometry is created for the rough cut, and the wire is going to move on the center of that geometry. And this slide kind of shows you that. So once I've done the program, it'll generate this code right here. You can see the green shape, and that wire will run right on the center line of that shape, and that's why you have to compensate for that. So the last technique I want to talk about right now is 4-axis programming. We get a lot of questions about 4-axis programming, how it works, how you should do it. Well, it's a type of taper machining. You know, you can just apply a taper if you want a T value, and it'll cut that angle. But this is a way to do it with 4-axis. And this is really common way to do tapering because so many people use solid models today. You can just extract these angles from the solid model. So when you do 4-axis, you have to create both an upper and lower profile. So everything we've done previously is just a 2D profile. In this instance, we're going to create both an upper and lower shape. With the Wire EDM, you need to think about a Wire EDM, what it is. So it is a true 4-axis machine. And what does that mean? That means that I have an XY on the bottom and I have a UV on the top. And they're totally independent of one another. So the way to look at it is I've got two 2-axis machines built on top of one another. Because of that, I can program completely different shapes on the bottom and the top. So this is a very simple shape here, little circle square. So I'd come into program, I hit ruled surface instead of standard profile. And then when I click on the workpiece, I have to create an upper and a lower figure. So obviously I'd create my geometry prior to this, and then I select it. So if you look here on the graphics, the blue is my bottom geometry or lower geometry, and the yellow is my upper geometry. I have a couple things that I have to tell it. Where is the lower geometry? So You can see in that window there, it says, what is the height? In this case, it's right at 0, which would be table level. The overall height is the distance between the two shapes. For this example, it's 2 inches. Now, I could move that part off of the table. If I'm on a fixture or something, if it's up 1 inch, well then my lower height would be 1 inch. It would not be 0, right? Because the table is always 0. And this software will compensate for that when it does its post-process. Once I do the program, this is the wireframe of the actual program that it creates. So you can see it's going to apply my angle, and you can see how the shape changes from a circle to a square gradually as you move up that angle, okay? So I do have an example of this one for a simulation. So let's take a look at that, just to give you an idea of what that looks like. So now we're going to come here and do the simulation. So you can see how the upper and lower head are going to move totally independent of one another. So I'm cutting a square on the top and I'm cutting a circle on the bottom. Come to my stop and it cuts the slug. Nice feature of this software, I can actually test this slug release. And so by clicking a button, it lets me know that that slug will come out of my parent part. The reason for that is because it is 4-axis, totally independent programming, I could write a program where I could lock that slug inside of my part and not be able to pull it out, just based on whatever shape I was cutting. So it is a very nice feature of Opticam. And that's that simulation. Okay, so that's it for the presentation. I just want to give you a quick overview of what the software has to offer, how easy it is to change your processing, change your concepts of how you want to do things. Right now we're going to go over to Alan Weeks, and Alan's going to give us a demonstration of the Opticam software. So Alan, take it away.
Thank you, Brian. Thank you for having us here today. We appreciate that, and we also appreciate everyone being in attendance today to watch this presentation. My name is Alan Weeks, and the name of our company is Camtek Optisolutions, and we represent the Opticam Classic Wire EDM programming software. I'm going to be demonstrating a function in our software that's referred to as Wire Expert. Many people will recognize this as automatic feature recognition or programming directly from a solid. Over the years, we've seen more and more companies only wanting to provide solid models for programming. So the need has never been greater to have the ability to quickly and efficiently program directly from a solid model. So that's what I'm going to show you today. So I hope you find this information useful. So this is just a typical die block that I have on my screen. This is a very common situation that you see, is that the file was saved in the incorrect orientation, and when we import it in, you kind of see what we see now. If I look at this in the top view, you can see that this is definitely not in the correct orientation. We want to have this view with our land at the top. So if I fit that back to the screen now, what I'm going to do to remedy that is I'm just going to right mouse click on this bottom face and select the face option, and select this option, rotate to plane, just to get it in the correct orientation, which in this case we want that face to be in the XY plane. We want to datum that plane and rotate all the solid items. Now if we look at this and we go to our XY view, you can now see it is in the correct orientation. So once we've done that, we can go ahead and start our programming process. So to first of all get what features that we want to machine in this block or create a program for, I go to our Wire Expert menu, and I just want to select this option called Automatic Feature Recognition. So in this first process, I'm just going to create features for all the internal die features only. This is just a clearance cutout, so I'm going to come back and do this as a manual feature. But to get all my internal features, I'm just going to select internal die features only, select OK, and then it will highlight all the features that it found. Okay, so if I look at this first group, you can see that it's found this hole. It's put it in a magenta type color that you can see, and then anything that's been grouped with it will be in yellow. So these are actually been grouped together, Now if I look at what else it found, I found these bolt holes. I really don't want to include those, so I'm just going to right mouse click on those and say delete group, because those are already going to be pre-drilled. And then also these lifter holes, I don't want to do anything with them. They've been pre-drilled as well, so I'm just going to delete that group. Then we have the heel and the land for the die opening has been found. That's good. Then this hexagon has been found. We want to wire that as well. And then the taper, okay, has also been found. Now, one of the things I wanted to point out on this is that you see we have arc to arc conditions here. This can sometimes cause undercuts when you have arc to arc conditions. So I know that's probably going to cause an undercut or an issue with the toolpath or the NC code, I'm going to force this in just a moment to output this as a 4-axis code instead of just a simple taper, a varying taper. Okay, so all that looks good. So I'm ready to go ahead now and create a manual feature for this clearance cutout. So I just go back to the top of the Wire Expert menu, select manual feature. I'm going to do manual face selection, and I'm just going to pick these 3 faces. And then I'm going to end the selection, finish feature, and then end the command. So now it has a feature created as well. Okay, so all my features have been created. Everything looks good there. So I'm going to go back to my XY view, and I'm going to create all my machinings. And it's also going to create figures or project everything at the correct heights based upon the solid model. So I'm going to select this option called Make Figures and Machining from the features. Not going to apply any technology. I'm going to do that later. I'm going to go ahead and create a billet or workpiece from the solid body. And this is the option I was talking about. I'm going to process all the tapered features as 4-axis. I'm going to select OK, and then it should go ahead and apply toolpath to all those openings. So we'll give it just a minute to do that. And that's exactly what it looks like it has done. So let's go ahead and finish the programming side of this. So I'm just going to start at the top of my machining list. So I'll go to my machining tab at the bottom. These are all the machinings that's been created from those features from automatic feature recognition. So I'm going to go to my operations sequence. I'm going to give it a part number, part description. I'm just going to call it a die block. All of this is optional. You don't have to do this. So you can put this in or not. Okay, it created a billet that you see here from the solid body. I'm going to give it an NC file name. Just call it anything there. This is where I'm going to post the file to this directory. I can post it directly to the machine if it's networked or whatever user specified directory that I want. Where am I going to start my program? In this case, I'm just going to say I'm going to pick from the corner of this block, and then the reference position, I'm going to pick up the same location there. And I can pick my datums, G92, G54, G500, G54. In this case, I'm just going to use a G92. If I go to my technology, this is the material I'm going to be cutting. It's steel. What wire type am I going to be using? Just brass 10 thousandths wire. Also, being that there's a lot of material being removed here, I am going to tell it to do all first cuts, all my rough cuts before I do any trim cuts. Okay, now that that's been done, I am going to come in here to my cylinders or my dowel holes. I'm going to go ahead and just pick these in the order that I want to machine them in this particular case because of where I'm starting at this corner. So I want this to be my first shape that I'm going to cut. So I'm going to do that. Now I'm going to select my technology based on 1.25 inch thick. So it brings up my select technology. In this particular case, I'm using the Makino U series. So I'm just going to do a 2-pass technology on pretty much everything. So 2 cuts there. This is the power settings, the offsets. So I load my technology, go to setup, 2 cuts. I'm going to put in a little bit of a clearance here. So I'm going to do minus 0.001 or a tenth per side, just to make sure that's a tap fit for those dowel holes. The tagging is the glue stop or the tab. We refer to it as tagging. So I'm going to put a 50 thousandths glue stop or tab there, and I'm just going to let it lead back to the center of the hole. And I'm going to stop and wire cut tags on the first cut. I'm going to lead on with the line, off with the line, and then we're going to cut counterclockwise with the wire offset to the left. And it's doing this because I'm using auto direction, which is mostly what you'll use most of the time. So I'll select OK to that and OK to this. This is where I could put comments in the code if I wanted to. In this case, I don't. So I'll just select OK to that. Now I'll do the heel and the land area for this opening. So I'll just go into here. Again, I'll just select my technology. We'll just do 2 cuts. So I'll select my nozzles as precision both away. Loaded up 2 cuts. We'll load technology. We'll go into setup. Pretty much do the same thing we did before. No clearance. We'll put in a tag distance again of about 50 thousandths. We will lead off about 30 thousandths. Drop the slug on the first cut. Lead on and off of the line. And then, of course, we're still using auto direction. So we'll say OK to that and OK to that. No comments in the code. So now we've applied technology for that. Now this hexagon here, we want to do something special to it. So I'm going to go into the standard profile operation for that, or the machining operation. We'll load 2 cuts again for this particular one. I'll use the same nozzle characteristics. We'll load 2 cut technology. Now in this particular case, instead of dropping a slug, I'm going to do a no core or pocketing operation, and I'm going to put in something like 0.125 as my start hole. But just to make sure that my hole location is good, the hole's not angled, I'm going to drop that down from the actual hole size, just so it starts no coring early and we don't have to worry about any short circuit or anything like that. So I'm going to no core pocket the first cut, standard pocketing, and I'm going to put an offset step-in distance of 6.5 thousandths, just a little bit more than half the diameter of the wire. Then my trim cut will be my second pass, and then all these other items will apply. Lead off, I'll just let it lead back to the start hole location, and then you'll see the tagging is grayed out because we're not dropping a slug, and all these options we can just say OK to, no comments to the code. And we'll just take a quick look at what the no core tool path looks like. So not dropping a slug, but just slowly eating that material away. So we did our no core. Then our ruled surface operation, remember we had that option set to output the taper as a ruled surface. So it's taking all this information from the model. Really, this is just clearance, a clearance angle. So in this case, I'm going to just do a rough cut only. So just a rough cut only. If I go into setup, you can see it has a rough pass offset only. Tag distance, we'll put in something, again, about like 50 thousandths. Well, in this case, really, we don't need a slug. Not going to have a slug to drop because it's such a slight angle. So I'll just say no tag removal for that, and then we'll just let it lead off back to the start hole location. All this is preset for us, so we'll just say OK to that, and then OK to that. No comment in the code. And then lastly, what we'll do is we'll load just a one-pass technology for this. Okay, so I'll just go to my select technology, use the same nozzle characteristic, and then we'll just select a rough and cut only, load technology, and we'll go into tagging. We'll give it something like a 50 thousandths tag, and we'll just let it lead off. Let's see, about 50 thousandths as well. Drop the slug on the first cut. All of this has been preset. Select OK to that. Okay, so once we've applied all the machining, done everything that we wanted to do, associated the technology, then we can run our simulation. So if I go to simulation, I'll start standard simulation. Okay, so we'll just center this, fit it to the screen. I have my speed control. It'll stop at my optional stops. So we'll just go ahead and select that. We'll zoom up. You can see it stopped at the glue stop or the tag. It's going to drop the slug. And remember, we're roughing everything out first, so it's doing all our rough cuts first, removing the slug, and it's going to come and cut our rough cut of the heel, straight heel area, and also the land area. We'll just speed this up just a little bit. It's going to drop the slug, then it'll do the no core. We'll definitely speed it up for that. So it's just slowly eating that material out instead of dropping a slug. Then it should, when it finishes doing the no core, it should go and cut our taper cut, the clearance for the land. And then lastly, then it'll come and drop the slug for the clearance. Then it comes back and does all the trim cuts. for the LAN. And I can reorder any of these that I want in the list. So the simulation looks good. That seems to be done. We can go back to our top view or XY view. If all the simulation looks good, we can zoom in and see graphically as well the number of cuts that it did as well. Then we just post-process our code, and then quickly and easily we were able to generate a program with different operations being done to it and have code ready to load into the Makino wire machine. So that's the steps of what you would do for using the feature recognition or the Wire Expert within the Opticam Classic. So I hope everybody found this information useful. And Brian, I will turn it back over to you.
All right, thank you very much, Alan. Now, Alan and I are both available for questions, comments, anything that you've seen today, and we're ready to take your questions now.
All right. So, Alan, thanks for that nice presentation there on the Opticam software. So I just want to point out we're available for questions that you might have. I noticed some people have already started putting some questions in the chat. That's great. I just want to point out to everyone that either the chat or the Q&A page there, if you have any questions, go ahead and enter those there. So let's take a look at some of the questions that we got already here going through. So Dennis asks, what do you consider small holes for no core? Well, you know, for me, it really depends on the start hole, right? And I think Alan kind of pointed that out with even that hex shape. If the start hole is bigger, you can still no core, and it's still beneficial. I just mentioned small holes because, you know, typically in a mold setting, if I'm doing core pinholes or ejector pinholes, if it's a smaller hole, you know, 1/8 inch or smaller, something like that, I would just always try to no core those because it's just easier because you don't have to put in such a small drill. But you could put in, you know, when you pre-drill it for the start hole, you could make a bigger hole, so you could no core that as well. It's really up to you as to how you want to process that. And it looks like Adam answered the question in the same exact way. So thank you, Adam. Dennis also asks, he says he's currently using Wiz, and what's the benefit to switching to Opticam? Well, to just give you some background there, Wiz is Opticam. So Opticam is just an updated version of Wiz, essentially. Wiz was branded for Makino, but it was created by Camtek. And we used to offer that as a cam system that Makino would sell and support. We're a machine tool company, and we're much better at being a machine tool company than being a software company. Alan and his guys are much better at being a software company. So we decided not to stop selling Wiz. And so we did offer customers the opportunity to transfer over to Opticam from Wiz. And it would be a seamless transition. So, you know, Alan, do you want to speak to that a little bit?
Yeah, that was a good point. We actually developed the Wiz software specifically for Makino, and they branded it as Wiz, like Brian said. All your native VDM files will still be compatible with the Opticam software. So any of your VDM files, we'd still be able to open. You'd still be able to use them. We did run a special and are still running a special for any Wiz customers that would like to switch over to the Opticam software. We have special pricing for that. So if you're interested in that, you can definitely get in contact with Brian or myself, and we can provide a quote for that. I know one of the questions you had is what is some of the main differences between the two. Really what I just demonstrated as far as the Wire Expert being able to quickly and easily program from a solid model, that was not available in Wiz. You had some manual type tools that you could use to work with a solid model, extract the 2D data from the solid model, which you can still do in the Opticam software. But that Wire Expert that I just showed you of where you'd be able to automatically find those openings, automatically apply the machining, that was not available in Wiz, which it is available in Opticam. So that's a really big benefit.
Okay, great. And another question here asking about slug removal. Can you choose early, late at the machine? So my guess is you're a AGI user. You can. Makino is a little different. AGI is unique in comparison to other manufacturers. We run straight on strict G code. There is an onboard programming system where you could just load the shape and you can change strategies. It's not nearly as easy as it is on the AGI, and I wouldn't recommend it. That's why we recommend for our customers to use something like Camtek, because it gives them that flexibility at the cam station, which makes it much easier. So to answer your question, not the way that AGI does it. It's not available on the Makino that way.
And Adam, I'm going to have to find out who Eugene is on The Walking Dead, because I need to find out who I sound like.
Okay. What else do we have here? Okay, what else? Can 4-axis be programmed in the machine instead of the computer? Well, 4-axis, you have to create the geometry. So I certainly would not try to do that at the machine. I'm going to use Camtek or another software or anything that's going to make it easier. Trying to hand write in a 4-axis program, not going to happen. Again, our controls, as most controls, we don't have a cam system on the control. What we can do is we can access with an optional software called HyperConnect. So if you're at the machine, you could access your computer remotely at the machine, and you could access your programming station from the machine and program it that way. If you really wanted to be standing in front of the machine to do it, that would be the best way to do that. Let's see. Okay, so the question from Martin. On the side slot, how close to the part does the machine do threading? Can I define a distance? So I think you're asking how close to the part you want to be when you do a thread. For the Makino, what I tell customers is I want to stay at roughly 100 thou away from the edge of a part. So if I'm on the outside of a block and I'm going to do a thread, I'm going to stay 100 thou away just to be safe. You can be closer than that, but if you have the space, that's what I do just by default, because that'll work on any machine, any version of our machine. Different machines with different threading systems can be a little bit different, but that's a general rule of thumb that I use. And let's see. Then I got a question here. Kevin using Mastercam. And does the offset scenario work the same in Mastercam? I can't answer that question. I don't know. I'm not familiar enough with Mastercam to be able to tell you how they apply their pocketing routines. There are some AEs at Makino that do use Mastercam. So if you have a question like that, I recommend calling into our 888 Makino 4 number for assistance, and someone can answer that question for you. Unfortunately, I can't really answer that question because I prefer Opticam. Let's see. All right, so Dennis is asking for a price now so he can convince his boss, Adam.
Yep, that's fine. I assume we got Dennis's contact information from where he registered.
Yep, we should have his contact information, I believe, and so Alan can get you something.
Yep.
Okay, let's see. All right, so here's another question. I kind of touched on this a little bit, talking about is there onboard programming with any Makino models? The answer is no, but we can use HyperConnect, and then you can access that programming remotely from the machine. So that's a way to do it. It's actually a more efficient way to do it, because then you're not utilizing the actual control computer, and you're not taking up all that power with a cam system. It's just remote, but you can access it at the machine. Let's see. When do I stack different materials Example top, brass, and bottom, some other material like aluminum or titanium. How to select technology? Well, my answer to that question is I normally would not stack different types of materials and cut them at the same time. And the reason for that is that every material has a different melting point, right? So the technology is designed differently based on those materials. So, for example, titanium, you have a titanium and aluminum. It's very, very different in the way those are going to machine. So generally not a good idea if you're trying to hold any kind of accuracy at all. If for some reason you have material and that's what you have to do, or that's how the material is designed or the part's designed, always start with a steel setting. So if you start with a steel setting, you might have to make some adjustments, but that's going to be your best bet in an instance like that. And let's see, lastly, we use programming with tab and 2 different paths with Slug. I'm not quite sure what that question means, unless you're talking about skimming the Slug, which you can do. You just have to hold the Slug so that it doesn't move.
Could be they want to apply a different technology for cutting that slug off.
Well, he just said ignore my third question. So okay, there we go. Quinn has one here. What is the best way to set up Opticam to be able to program easily across multiple different wire machine platforms? So I think, Alan, you can answer that question much better than me.
Yeah, I think I know why Quinn's asking this question. I think he's got the U32J, I believe, Quinn, and he just got that UP6 heat control. Probably
Gotcha.
what he's wanted to do is set up 2 different machines for profiles for each machine. You can definitely do that. Basically, what you do is you install a new Makino post, and then you specify what machine it is. You can give it a specific name. So you would have your current one that you had for the 32J, and then we'd set up one for the UP6, and each one would have its own individual technology data per machine.
All right, very good.
And we are working on that, Quinn, for your technology for that new machine. So we got something today from development, so we should have that to you soon.
Awesome. Okay.
I think we had one in Q&A as well, Brian. I don't know if you saw that one or not.
Yep, I just went over that one. It's from Derek, and he's saying he was hoping this webinar would cover technologies and settings such as off time, on time A, B, etc. So that's not what this one's really about. I can touch on that a little bit, but I don't want to go into too much depth on it. The best resource would be for you to call in to 888-Makino-4. We always have a application engineer available to take calls and to ask that question from them. They can answer those questions and really explain what some of those things are. As far as the quick and easy way, our machine has the Easy Cut slider bar on it. That will adjust your power settings. That changes 3 settings inside of the technology. Okay, it's going to change your IPM, which essentially is your initial power. It's going to change your speed setting, how fast it's going, and it's going to change your off time. So it has a plus and a minus to it. So the reason we're not changing on times is because if you change on times, you're really changing the size of the spark gap, which can affect your size and your accuracy. So that's why we steer away from changing that, on a general slider like that. So that's one way that you can go back and forth and kind of tweak that in. But for more in-depth detail, I would say, call into Makino, and there'll be somebody available that can answer those questions for you. Let's see. Can you create? So here's one, Alan, from Edgar. Can you create a wire path from a 2D model?
Yes, absolutely.
Yep.
You can bring in a DXF file, 2D data. You can draw your own data in the software. We can also have a tool that if you import a solid model and you want to just get 2D data from that solid model, you can do that. So yes, in the end, we can program directly from 2D lines and arcs. That's no problem at all.
Okay. Then another one. Let's see. Video, someone's asking for a manual PDF or a video lesson for Opticam. Is that available?
Yes, we have a manual PDF. We have also manuals help within the software, and then we are trying to increase our video library as well for different functions, specific functions that you can do in Opticam. Matthew, I made a note of that. I don't know what company you're with. I know your name sounds familiar, but I can definitely send that to you. But if you were registered, I should have your contact information.
And then Ron's asking about the dye slug retention.
Yep, we can actually send you something on that, Ron. We've got, a couple of videos that we've done. I think you're using it now, aren't you, Ron? The slug retention. I know we won't have time on this particular session,
right,
but we can definitely send that to you.
Well, I think that's a good segue into what I want to let everyone know that's still on the call here. We're going to be having a follow-up presentation to this one, looking like it's going to be in July. We'll probably touch on some more programming techniques such as slug retention. I thought that might be a good one for us to touch on to show you how that works, and some other features and techniques. But then also we're going to highlight the Optisolutions version of software that functions in the native SolidWorks environment. Correct, Alan?
That's right. That's right.
Touch on that a little bit. Explain that to them.
Yeah, that's fine. Most everybody here, we've got customers going way back. Bob Hankey, he's been a long time customer. Say they got a Makino hole popper. Is that correct, Bob? But they've been using the software as the standalone version that runs, outside of any specific CAD system. But also we have a software that's been developed within probably about the last 10 years that actually plugs into SolidWorks. So it runs inside the SolidWorks environment. You can do all your solid modeling inside SolidWorks. And while you're there, you can go ahead and generate a program for the files that have been created inside SolidWorks directly in SolidWorks. So it is a totally different system from the standalone. A lot of the development was done based on the standalone product, but it is a completely new developed system specifically for plugging into SolidWorks.
Okay, great. And like I said, we will have a webinar highlighting that in July. Ross asks, can I get a copy of this recording? This recording will be posted on the Makino website, and there will be a link on there. You can go to Makino's website. There's an events page. You go to that events page, and any webinar that we've done will be posted there, and you can watch it whenever you want to watch it. So it'll be there and available for you to take a look at your leisure. So, okay, well, I want to thank everyone for taking time out of their day today. I know that it was the start of March Madness, so you guys probably missed some of the basketball games, but I'm glad you spent the time with us. And again, if you have any questions, shoot me an email or Alan, and we'll get back to you. So thank you, everyone, and we'll see you later.
Yep. Thank you, everybody. Thanks, Brian, for having me.
All right. Thanks for coming.
Okay. Bye now.